Hello everyone, hope you are doing well. Welcome back to 6th session of this IoT course. Last session I have demonstrated how to implement basic programming in Arduino platform. I have demonstrated blinking LED by using Arduino. Today I will demonstrate different projects, right, and the sensor programming using Arduino. So guys, let's start. First open the Tinkercad. Already I have discussed this thing, how to create account. So now I will demonstrate that how to develop Arduino based project by using sensors and Arduino. So guys, first log into Tinkercad.com. So I have already logged in. That's why you can see the dashboard of Tinkercad. So click on circuits. First I will design smart parking system by using ultrasound sensor, okay, and Arduino. So let's start with create new circuit. You can see guys, this is a workspace. So now drag one Arduino board. It is better you can just rotate this board a little bit. Okay, no issue. So now you can take one ultrasound sensor. I guess you can rotate a little bit. Okay guys, so now this is ground and this is the data pin. I think you can see guys, this ultrasound sensor that actually helps to measure the distance. So this is ground, this is 5 volt, and this is the pin. This is called the pin for receiving and generating signal ultrasound. Okay, so first I will connect this ground. Okay, this I think I can also do in this way guys. So I loaded a little bit in this direction. It is better. Okay, so now it is okay guys. So now what you can do, you can just connect the wire. First I will connect the ground pin from here. Like this. So I think you can see guys, this is the ground pin. Now just connect it to the ground, and first part is over the ground. So now connect this 5 volt pin. This is the 5 volt. This is 5 volt. This is ground. We can connect also this ground, but I have chosen this because I have to connect one LED over here. So now we connect your data pin. There is a pink pin over here. This is pin number 7, right? So now we can connect a one LED. So I'll tell you the basic principle of design. Just a minute. So now rotate it. So now use one resistance or resistor. So this is one resistor. I can use this one, guys. Rotate. Okay. So now we will connect to here. Just to check. This is cathode. Okay. So this is, you can connect over here, and you can connect to GND. This is ground. Done. And this anode is connected to pin number 13. So you can connect to any pin, guys, but I have chosen 13. Okay, no issue. So okay, so now circuit diagram is over. What is the basic principle of this design? So the idea is that so whenever a car is coming to a parking slot, the sensor will sense the distance. If it is very close, then it will open a gate. That is the basic parking system. Okay. So now the LED is behaving as a gate, because as soon as the distance is less than 100 centimeter, the LED will glow. That means you have to open the gate. Okay. That is a basic understanding. Okay. So now I'll explain what is the basic principle of ultrasound sensor measuring distance. So the idea is that generally in the market, whatever ultrasound sensors are available, so actually it has 4 pins, right? So but over here in this simulator, you have only 3 pins. So one is the ground, and one is a 5 volt, and one is a pink pin or data pin, whatever you can see. So what the basic principle of ultrasound is that measuring distance is that is in the one pin, the trigger pin will generate the ultrasound signal, and it will bounce back, and there is a one pin called the echo pin. The trigger pin will generate the signal, ultrasound signal or sound signal, whatever you can say, and after that other pin, there is the echo pin, will receive the signal. Then you have to calculate the duration between this, the sending and receiving. Okay. And then you have to convert into corresponding centimeter or any unit. Okay, that is the basic principle. But in this case, we have only one pin. That's why this one pin will generate the signal. Okay, and this pin also receive the signal. Then you have to calculate the duration, and then you have to convert into the corresponding centimeter. Okay. So now I'll write the code. So I have already written the code. Just a minute. I'll give this code to you in description box. So I'll explain this code. I think you can see, guys, this is the pin, that means the data pin, which is connected to pin number 7. You can connect it to any pin, whatever you want. Then you have another pin called the LED pin. Actually, I think you can see the LED pin, the anode is connected to 13, pin number 13. Okay, this is the output pin, you can say, because the output is going from pin number 13 to this LED. Okay. So now this is a setup function where I have added one function, that is it's called serial.begin 960. That means it is the baud rate. Okay, so that means the serial communication. Okay, so initialize the serial communication speed with the serial monitor which is available over here, guys. Okay, and with the serial port. And I've used a pin mode function for initializing the LED pin, that is the output pin, that is pin number 13. And I have taken two variables, one is long duration and the centimeter. Okay, now I have initialized the pin over here as output pin, that is pin number 7, and then digital write pin as low. That means first we initializing to low and then initializing to high. That means, so now we can say first initialize to low, so then the pin initializes to high. That means it's generating the signal. The pin generating the signal. Now for 5 microsecond, and then it's set to low. Okay, then after that the pin will receive the input. Okay, so that means the signal, and we find out the duration between sending and receiving. Okay, and then you convert this duration into this, like this, in the centimeter. Okay, this is the function, the microseconds to centimeter. Okay, so then you can also print the centimeter. That means the how close your object. So then if the centimeter is less than 100, that means you can LED pin is high, that means you have to open the gate. Okay, and if it is not less than 100, this is low, that means please do not open the gate. So I am making a one delay also. And in this particular function, I have written a one user different function, this is microsecond to centimeter. So this is the one. So return the microseconds divided. This is a standard formula we have used. Okay. Okay. So now I'll run this code. So you can see the distance is now 113.4 centimeter. So in the code I have written, if it is less than, then only the LED will glow, less than 100 centimeter. So just see this one, just see this one. 99, oh, off. 99.8, yes, blinking, off. So if it is less than 100, LED is blinking, that means you have to open the gate. If it is greater than 100, you have to close the gate or do not open the gate. So that is the idea of the first project what we have. This is a very simple one to implement. So I haven't mentioned any kind of parking slots and if the car is available. So now I'll show you this thing. Just a minute, I'll demonstrate it. First I'll stop this one. And go to the dashboard once again. So now I can show this multiple parking. Already I have done this thing. Please wait a minute. Just you can see, guys. Just open it by clicking Tinkercad this. Okay, guys. So the same thing, but I have used 3 ultrasound sensor. So I can go through the code also if you want. So just start simulation. So just think if is this one. So okay, nice, you can see, right, depending on distance. So red means means not possible, green means you can enter, as you can see guys. Okay, so now stop simulation and go to the code. You can check the code similar way, centimeter 1, centimeter 2, centimeter 3. Already I told you. So use of centimeter. Then we have free and taken, that is the enum. And then we have checking, and then update display, right? So we have current slot 1 is free. Initially all are free, all slots are free, and the current main is basically the checking. So now you can see guys, is one pin mode. We are initializing the pin, and then it should be low, because already I told you that's for high and low initialization. So this is the way. That's it, guys. Now I will demonstrate the actual parking systems. So I have created 3 parking slot, and I've used 3 ultrasound sensor for it. Already I told you how to use ultrasound sensor in smart parking in last application. Okay, so now this is the actual real parking system. What I have done over here, you can see guys, we have used 6 LEDs. So the red showing that the slot is booked, and the green means it is not booked. Okay, that means not allocated. Initially all are green. As soon as one car enters into this slot, it is showing red. Okay, the red LED will glow. Okay, so that is the basic objective. So let's run this code. So I used one flag for actually for maintaining this thing, whether it is booked or free. And go to the code. You can check the code similar way, centimeter 1, centimeter 2, centimeter 3. Already I told you. So use of centimeter. Then we have free and taken, that is the enum. And then we have checking, and then update display, right? So we have current slot 1 is free. Initially all are free, all slots are free, and the current main is basically the checking. So now you can see guys, is one pin mode. We are initializing the pin, and then it should be low, because already I told you that's for high and low initialization. So this is the way. That's it. Start simulation. Guys, so now you can see all showing red, right? So better I increase it a little bit. And the distance is, here I have given 200 centimeter. If it is less than 200 centimeter, then only the red LED will glow, because that indicates that car is very close to parking slot, and if it is not booked, the car can enter into this slot. Okay, this one and this one. Okay, so just you can see guys, all slots actually. So for first car, first 2 LED, red for already allocated, green fields it is free. Okay, so now it's showing, this application is showing that all the slots are free. So now I'll check. So now I want to enter into this slot, right? The parking slot. That means I want to enter my car into this slot. So what we'll do? So this is less than 200 centimeters, series one. The red LED will go. That means it is booked now. If you just do like this, if it's less than 200, it's booked now. Red LED will go. So now if you do like this, if it's less than 200 centimeter, the LED will glow. So this way we can manage the entire parking system. So whatever I have done in last program, more or less is similar. The only thing that I have used one flag to understand whether it is booked or not booked. Guys, this is all about the smart parking system. I think you understood very well. Okay, thank you very much.